Welcome. See this question. If fxy is a continuous function defined over xy with 0, 1 and 0, 1, given the two constraints as x greater than y square and y greater than x square, the volume under fxy is which of the four we have to choose. Read the questions carefully and see these constraints. These things, even knowing parabola represents y square equals to 4x is like this, and x square equals to 4ay is like this. So, but it is giving 0, 1. So, we will omit this lower portion. It is no negative value is there, so we will reject this one. So from here, these are the where these two curves are intersecting. This is one point and this is one point. From if it is equations will be suppose x equals to y square and y equals to x square. So the corresponding points will be 0, 0 and 1, 1. Without calculation itself we can say, or 1, 1 if both the equations are satisfied. For 0, 0 both the equations are satisfied. Now what we have to do? We have to find the volume under fxy. You are knowing this double integral represents the volume. So the limits are 0, 0, 1, 1 we are knowing. Now we are knowing when these two functions are there, we can see one by one without any calculation. It is not required. You have to understand how to do it. Even drawing is also not required. But here I have shown this 0, 0 and 1, 1 point. So one possibility is if y the limits are 0, it's constants, then x the limits can be expressed as a function of y. Here in this it is partly constant, so it cannot be this one cannot be the answer. Okay, here both of those are constants. It is possible, but when both y1, y2 constant, x1, x2 constant, then the graph will be, suppose these are x1, x2, these are y1, y2. Automatically it will be a rectangle, but we are observing it's not a rectangle. So we can reject this one also. And this one is y is expressed not as constant, so we can reject this one also. So only remains is this one, and we are finding y equals to 0 to 1. As we are observing, y limit is from 0 to 1 and x is expressed as a function of y. So actually without doing drawing also, we can detect this will be the only possible. You have to remember when this double integral is there, this one we are always expressing in terms of constants, and the second one in terms of function of the other one. So in this way, by seeing this one, we can easily choose that this will be the answer. Now see this question, a cubic polynomial with real coefficients. Now options are given. A can possibly have no extrema and no zero crossing, may have up to 3 extrema and up to 2 zero crossings, cannot have more than 2 extrema and more than 3 zero crossings, will always have an equal number of extrema and zero crossing. So in this sum, we need not require to calculate anything. We have to think. What is a cubic polynomial? You are knowing in any polynomial the number of zeros is equals to the number of maximum power of the variable. Cubic means maximum power is 3, that is degree is 3. So in this case the number of zeros will be 3, but all those zeros may not be real. There may be real or imaginary. So imaginary roots always remain in pair. So there will be either 1 zero crossing or 3 zero crossing. It cannot be more than 3. So we can say more than 3 zero crossing. This one is only the correct option for number of zero crossings. Now for extrema, extrema means either maxima or minima. You are knowing for extrema when it is coming, when f dash x, fx is a cubic polynomial. So f dash x, you are knowing it without doing that it will be a quadratic polynomial. A quadratic polynomial, so it can have 2 zeros. A quadratic polynomial can have 2 zeros. In other words, it can have 2 roots. Those 2 roots may be real, may be imaginary, but it cannot have more than 2 roots. So cannot have more than 2 extrema. So this is the only possible option. Because can possibly have no extrema and no zero crossing. It's not possible. So this is the only option we have to choose from here without doing anything. In this way you have to learn how to do a sum. If idea is very clear, consider the shaded triangular region P shown in the figure. What is the double integral of xy dx dy? See here, so we have to this region, we can see from the figure the equation of the line will be x by 2 plus y by 1 equals to 1, or we can say x plus 2y equals to 2, or 2y equals to 2 minus x. So y equals to 2 minus x by 2. Now this integral we can do it as integral of suppose for x we are finding it is from 0 to 2. If we are writing from 0 to 2 and here it is for y equals to 2 minus x by 2. So it will be y equals to 0 to 2 minus x by 2 xy dx dy. We are converting this one in terms of x. So this one can be written as 0 to 2. Now this one integral of this one, while doing this one y dy, we have to consider x as a constant. So it will be x into y square by 2. Limit is from 0 to 2 minus x by 2, and this one dy. So this is equals to 0 to 2 from x by 2 into y square, that is 2 minus x by 2 whole square. For 0 it will be 0, we are not writing this much. Sorry, here it will be dx. So this much dx. So this one equals to, now we can say this is equals to integral of 0 to 2. This 2 square will be 4 and 2 8. So 1 by 8 we can take outside. So it will be x into 2 minus x whole square, that is 4 minus 4x plus x square dx. This is equals to 1 by 8 from 0 to 2, 4x minus 4x square plus x cube dx. 1 by 8, now it is 4 into x square by 2 minus 4 into x cube by 3 plus x to the power 4 by 4, and the limit is from 0 to 2. So you can do it. 1 by 8 keep outside, 2 to the 4, x 2 square into 2 will be 8 minus 2 cube is 8 for the 32 minus 32 by 3 plus 2 to the power 4 will be 16 by 4 is 4. For 0, everything will be 0. So this is equals to 1 by 8 into 3 12 is 36 minus 32, that is 4. So this becomes 1 by 6. So see the option. So option A, this question. For the function fx equals to x square into e to the power minus x, the maximum occurs when x is equals to which one of these? So fx equals to x square into e to the power minus x, and directly doing f dash x equals to 2x into e to the power minus x plus x square into e to the power minus x into minus 1, that is 2x e to the power minus x minus x square e to the power minus x. Let us do f double dash x also equals to 2x into derivative of e to the power minus x will be e to the power minus x into minus 1 plus derivative of 2x is 2 into e to the power minus x minus x square is 2x. X square e to the power minus x was here. So this one we can copy. 2x e to the power minus x minus x square e to the power minus x. So this one is minus 2x e to the power minus x plus 2 e to the power minus x minus 2x e to the power minus x plus x square e to the power minus x. So we can say it is 2 e to the power minus x. This one and this one is same. So minus 4x e to the power minus x plus x square e to the power minus x. Now we are knowing there will be maxima when f dash x is 0. F dash x is, if we are taking x e to the power minus x common, what remains? 2 minus x. So this one equals to 0. From here we can say e to the power minus x can never be 0. So either x equals to 0 or 2 minus x equals to 0, that is x equals to 2. So for these two values, f dash x is becoming 0. We will check for these values what will be a double basis. So f double dash 0 equals to e to the power 0 is 1, so it is 2 minus this is 0, this is 0. So 2 means positive. Even being positive indicates minimum. So this is not our solution. So without doing, we can say 2 will be the only option. Still we can check it. We can take the answer. Answer will be 2 at x equals to 2 because 0 is not valid. F dash double dash 2, I am showing you it is not required, equals to 2 by square minus 4 into 8 by square plus 4 by square. So that is what is 2 plus 4, 6 minus 8 minus 2 by square. Hence it is coming negative and this one indicates maximum. So our choice is correct. In this way you can do these sums